Hi, in this video, I'd like to clarify a few more things about inheritance and polymorphism. So we'll continue to use our person example, and I like to show that, okay, so if we define a staff class that inherits from the person, and the staff class uh, doesn't define any code, and then are we able to just use the staff class as it is? Well, if we run this, we instantiate a staff and then we can print out a staff. So yes, it just works, right? Now, what if we do something a little different? So we actually overwrite the dunder init method, yet we don't put any code in there. Would this code continue to work? So if you'd like to think about this yourself a little bit, pause the video and think about it. And let's try to run it. What happens here is that it actually does not work. And in this line of code, or when we try to print it out and it tries to call the dunder string method, here it complains that the staff object has no attribute first name. And the reason for that is that even when we override this DAF's dunder init method, we didn't do anything here, okay? And so it did not create the instance attribute first name or last name at all. So, so the important lesson here is that when we override the method, it does not automatically call the super's same method for us. So in this case, we overwrite the dunder init instead, but it does not automatically call the person's dunder init method. Okay, so if that's what we want, if we want to call the person's dunder init method, we have to explicitly call it. So we have to explicitly say, before I actually do that, PyCharm actually warns us that call to dunder init of superclass is not there. Okay, so so we have to explicitly call it. Sorry, dunder init first name and last name. All right, that's what will keep it working. And so the second item here is a little more about polymorphism. That, okay, so we've seen the example of printing worries that, it doesn't matter what's in the list of people. We can just call the p dot worries, and depending on the type of the people, it will print out different worries, right? That's the example we use for polymorphism. Now, what if somebody who does not understand or know about polymorphism, and how would he or she write the print worries method, right? And remember, the goal is, depending on the type of the elements, the type of the person in the people list, we want to print out their different worries, right? Depending on the type. So how would somebody not using polymorphism write print worries? Well, they'll end up with something like this, most likely, that they will be checking the type of P, right? So if the type of P is person, then the person worries about money. And if the type of P is teacher, worries about money plus lecture, and the type of P is student, then they'll be worried about money and quizzes and assignment. So, and so, okay, so that would work, but is there a problem with this? Well, there are a couple problems with this. So first of all, what the person or what the teacher or what a student worry about, I mean, those information should really be part of the type itself, right? So, like for example, what a student should worry about should be part of the student class rather than in the print worries function. So it kind of violates the principle of data encapsulation, right? The information is in the wrong place. And then the second problem, which is also a very big problem, is that imagine there are 10 different type of persons, or I don't know, 20, 30, 50, 100, right? This else, if block will get very, very long, and it will be unreadable and unmaintainable. So that's a really bad way of writing code. So I hope that this gives you another reason to appreciate how elegant and how flexible and powerful polymorphism is. And the third item is on polymorphism and kind of the runtime dispatch, or which method it actually calls when the code is executed. So now going back to the similar examples that we saw earlier, that with the person class, now if we define an initial method for person class, and we take just the first letter from both the first name and the last name, and then we have a sign with initial method that just prints out signing with initial and call the initial method, right? So when we instantiate a person class and call the sign with initial method, it should be very obvious that the self.initial here, this initial method calls the initial method that is defined in the person class, right? So if we run this code here, yeah, basically, because we initialize John Doe, and therefore it's signing with the initial JD capitalized. Now, next, what if we define a new class, teacher, right, and it overrides the initial method? It will call the super.initial and then change it to lowercase. Okay, so the question then is when a teacher instance called the sign with initial method, which is only defined in the person class, right? And that sign with initial method, it then calls self.initial. Then which initial method is it going to call? Is it going to call the one that's defined in the person class, or is it going to call the one that is defined in the teacher class, which is added after this code has been written? And if you want to think about it, pause the video, think about it for a moment, and I'll just run the code now. And so it would actually so if you can see sign with initial, actually the initial is a lowercase initial. So apparently it is calling for a teacher instance, it is calling the teacher's initial method. Even though, again, this method was written after this sign with initial method was written. And so how does that work? Now, the reason it works is because Python is a dynamically typed language. So at runtime, or when the program is actually executed, at that time it figures out the type of the objects, right? And not, critically, not when the code is written. So it only figures out the type when the code is executed. So when the code is executed, the Python would know that this instance is type teacher. So when it calls the sign with initial here, and then that method calls another method, just dot initial, it knows that this self is an instance of teacher. So it would then call the teacher's initial method, not the person's initial method. Okay, so again, that is because which method it calls, it depends on the actual type when the code is run, not where the code is when the code is written. So this is kind of just another very nice example of polymorphism, that the code that is written can actually behave differently depending on what it is. Right? That initial method, it may call the person initial if it's actually called from a person's instance, or it can call the teacher's initial method when the instance is actually the teacher type. We're talking about Python here, but this is not a unique feature of Python, right? Most other languages that actually supports object-oriented programming, inheritance, as well as polymorphism, they do exactly the same thing. And finally, just one exercise for you, and that has to do with I would like to make sure you understand the difference between type and instance. So given this very familiar inheritance hierarchy, and if we look at a few of these expressions, what do they evaluate to? So it's either they all evaluate to Boolean true or false, but which one is true, which one is false? And assuming that you have done it, here are the answers. Please verify them. So the key to remember is that type return the exact class or the exact type of a given instance. So for the teacher variable here, the type is teacher. So the only thing that evaluates to true is when it's compared to a class teacher, right? Whereas instance check the class itself and all the ancestors. So in this case, teacher is an instance of person because teacher inherits from person, right? And teacher obviously is an instance of teacher itself, but teacher is not an instance of student because teacher or any of the ancestors, none of those is the student class. So in the world of inheritance, it's often desirable to use each instance to check for the type, unless you explicitly need to know the exact type of an instance, in which case then you use the type function.